In question 1, we have to find the set of values of m for which the line with equation y equals to mx plus 1 and the curve with the equation intersect at 2 points. Now, if a curve and a line are intersecting, to find the points of intersection, we solve the equation simultaneously. So this will be, we write it as 3x squared plus 2x plus 4, which is the equation of the line, equals to mx plus 1. Now, as we have an unknown constant m over here, so we'll have to use the discriminant b squared minus 4ac to find the value of m. So first we can simplify to write it as 3x squared plus 2x minus mx plus 4 minus 1 equals to 0. Taking x common, so this will be x bracket 2 minus m plus 3 equals to 0. So as the coefficient of x square is 3, so a will be equals to 3. The coefficient of x is 2 minus m, so b will be equals to 2 minus m, and the constant term is 3, so c will be equals to 3. Now, as they're intersecting at two different points, it means b squared minus 4ac will be greater than 0. So writing 2 minus m, which is b whole squared minus 4 into 3 into 3 as greater than 0. Expanding, we'll get 4 minus, so 2 times 2 will be 4, so this will be 4m plus m squared minus, this will be 4 times 3, 12 times 3, which is 36 as greater than 0. Simplifying, we'll get m squared minus 4m, and 4 minus 36 is minus 32 as greater than 0. Factorizing this, so this will become m minus 8 and m plus 4 as greater than 0. Now, to give the correct inequality sign, we'll make the quadratic curve and try and figure out the correct signs for these values. So one of the values of m is 8 and the other value is minus 4. Now, as this has to be greater than 0, we can see that this graph will be positive if we move to the left, to the right from 8 and to the left from minus 4. So the values of m will be, m should be greater than 8 and m should be less than minus 4. In question 2, the equation of a curve is such that dy dx is 3x power half minus 3x power minus half. It is given that the point 4, 7 lies on the curve. We have to find the equation of the curve. Now, to find the equation of the curve, we'll have to integrate the dy dx. So first we'll write it as dy equals to 3x to the power half minus 3x to the power minus half dx. Now integrating both the sides, so integrating dy, we'll get, so this will become y is equals to, increasing the power half by 1, so that will become 3 upon 2. We'll divide by the new power, which is 3 upon 2, minus, we'll increase 1 upon 2 by 1, so that will become positive 1 upon 2, and we'll divide by the new power 1 upon 2, and we'll add a constant plus c. We can simplify this to write it as, so this will become, the 2 will go in the numerators, it will become 2 times 3, 6, 6 upon 3 will be 2, or we can just cancel this 3, and we can write it as 2x to the power 3 upon 2, minus this 2 will multiply by 3, so that will become 6x to the power 1 upon 2 plus c. So once we have the value, once we have simplified this, now we can substitute the value of x and y in the equation. So y is 7 and x is 4. So this will be 2 into 4 to the power 3 upon 2 minus 6 into 4 to the power 1 upon 2 plus c. Simplifying this, 4 to the power 3 upon 2 is 8. So this will be 2 into 8 minus 6 into 2 plus c. 2 into 8 is 16. 16 minus 12, so that will be equals to 4 plus c. So c will be equals to 7 minus 4, which is positive 3. Once we have the value of c, we can write the final equation as y equals to 2x to the power 3 upon 2 minus 6x to the power 1 upon 2 plus 3. In question 3, in each parts of ABC, the graph shows the graph shown with solid lines has equation y equals to f of x. The graph shown with broken lines is a transformation of f of x. So in part A, we have to state in terms of f the equation of the graph shown with broken lines. Now, if you look at the graph with the broken line, we can see that it is a reflection of y equals to f of x in the y-axis. As this point is equal distance from the y-axis, this point and this point, they are both equal distance from the y-axis. So if we have a reflection in the y-axis, so that will mean we'll write, if we have a function f of x, if there's a reflection in the y-axis, it is written as f of minus x. as the x values have switched. So the equation of the graph with the broken line will be f of minus x. In part B, we have to now again state the equation of the graph with the broken lines. So now in this case, we can see that the x values have remained the same, but the y values have doubled. So this value is from 2, it has gone to 4. This point at y equals to 1 is at 2, and the point at y equals to 3 is at 6. And the x values have remained the same. It means there has been no other transformation other than a stretch. So there has been a stretch and the scale factor is 2. So if there is a scale factor of 2 and a stretch, so the whole function multiplies by 2. So this will be 2 into f of x. In part C, it's again, we have to state the equation of the graph with the broken lines. Now we can see that this is exactly the same as the broken line. So f of x, there has been no stretch or reflection. However, it has moved in the x and the y direction. So we can see that f of x has moved. So if we take, let's say this point over here, it has moved 1, 2, 3, 4 units towards the left. So it is a translation, first of all. First, we can write the vector and then we can write it in the equation form. So there has been a translation of -4 and it has moved 1, 2, 3 units downwards. So -4 and -3. So if there's a translation of -4 and -3, it is written as f of x. So if this is a minus over here, we write it as plus x plus 4. And this -3 is basically, we subtract 3 from the whole function. So this will be a -3 up here. So this will be the equation for f of x after it has been transformed. In question 4a, we have to expand 1 plus a to the power of 5 in ascending powers up to and including the term in a cube. Now, first, we need to know that the expansion formula for 1 plus b to the power n is 1 plus nc1 b to the power 1 plus nc2 b to the power 2 plus nc3 b to the power 3. And as we just have to give it till a cube, so we'll stop at nc3. Now, so as you're expanding 1 plus a to the power 5, so this will be 1 plus 5c1 a to the power 1 plus 5c2 a to the power 2 plus 5c3 a to the power 3. Now, substituting 5c1 in the calculator, that is 5, so this will become 5a. 5c2, if we substitute this in the calculator, that is 10, so that will become 10a squared. And 5c3 is also 10, so that will become 10a cube. So this will be the expansion up till a cube. In part B, it says, hence expand 1 plus x square up to and including the term in x cube. Now, as you already have an expansion of 1 plus a to the power 5, and that was 1 plus 5a plus 10a squared plus 10a cube. So we can see that this a has now been replaced with x plus x squared. So in place of a, we can write x plus x squared. So this will become 5 into x plus x squared plus 10 into x plus x squared whole squared plus 10 into x plus x squared whole cube. Now, as we just have to expand up till x cube, so if you open up the brackets, this will become 1 plus 5x plus 5x squared. Now, expanding x plus x squared, that will become x squared plus 2. So this will become x cube, and this will become x to the power 4. And x plus x square whole cube, we do not want any power more than cube, and the lowest power over here will be a x cube. So let's say even if I expand x plus x squared and I expand it, so that will become x squared plus 2x cube plus 10x to the power 4. So well, expanding this will become an x cube. So first we can expand x plus x squared. So that will become x squared plus 2x cube plus x4. And as it is a whole cube, so you'll have to multiply it again by x plus x squared. Now, if I expand this expression for x plus x square whole cube, so that will become 10 into x square into x, that will become x cube. And all of the powers that we multiply will be greater than x to the power 3. So we can ignore those values and we can leave it till x, leave it till the first term, which is x cube. So simplifying this, we'll get 1 plus 5x plus 5x squared plus 10x squared plus 20x cubed. And as we do not want a power in 4, so we can leave 10x to the power 4. And this from the third term will get 10x cubed. So this will be a plus 10x cubed up here. Simplifying this expression, the final answer will be 1 plus 5x. 5x squared plus 10x squared will become a 15x squared, and 20x cubed plus 10x cubed will become a 30x cubed. So this will be the final answer for the terms including till x to the power 3. In question 5, the diagram shows a cord going around a pulley and a pin. The pulley is modeled as a circle with center O and radius 5. The thickness and the size of pin P can be neglected. The pin is situated 13 centimeter vertically below O. Points A and B are on the circumference of the circle such that AP and BP are tangents to the circle. The cord passes over the major arc AB of the circle and under the pin such that the cord is taut. We have to calculate the length of the cord. Now, the length of the cord basically consists of 3 lengths. One of them is the length of AP and the length of BP. They both will be equal. And the arc length of AB, or we can say that the major arc, we have to find the arc length of the major arc AB. Now, in the first step, finding the length of AP, we can apply the Pythagoras theorem. So as it is a right angle triangle, so AP squared will be equals to 13 squared minus 5 squared. So AP squared will be equals to 169 minus 25, which is 144. So AP will be equals to 12 centimeters. Now, as AP and BP will be equal in length, so BP will also be 12 centimeters. To find the arc length of AB, first we'll have to find the angle AOB, or the reflex angle AOB. To do that, first we'll find the angle AOP. So as it is a right angle triangle, we can write cos of AOP will be equals to adjacent, which is 5 upon 13. Taking cos inverse of 5 upon 13, so this will be shift cos inverse of 5 divided by 13. This angle will be 1.176 radians. So angle AOP will be equals to 1.176 radians. So the total angle AOB, or we can say that this obtuse angle AOB will be equals to 1.176 multiplied by 2. So multiplying this answer by 2, this will be 2.352 radians. Now, once we have this angle, we can subtract it from 2 pi to get the angle AOB, or we can say call it the reflex angle AOB. So that will be 2 pi, which is 360 minus this angle that we found, which is 2.352. So 2 pi minus this answer will be, so 2 multiplied by pi minus answer will be 3.93 radians. Now, once we have this angle, we can find the arc length using the formula S equals to R theta. So as the formula is S equals to R theta, the radius given in the question is 5 centimeters. So this will be 5 multiplied by 3.93. Multiplying this by 5, we'll get 19.655 centimeters. And finally, the total length of the cord will be, so the length will be equals to 12 plus 12, which is 24, plus 19.655. That is equals to, so adding 24 to it, this will be 43.655. And as we have to give our answer to 3 significant figures, so the final answer will be 43.7 centimeters. In question 6, a point P is moving along a curve in such a way that the x-coordinate of P is increasing at a constant rate of 2 units per minute. So this means that the dx by dt, the rate of change of x, is given as 2. The equation of the curve is y equals to 5x minus 1 to the power half. We have to find the rate at which y coordinate is increasing when x equals to 1. Now, the relationship between the change of y and change of x is given by dy dt equals to dy dx multiplied by dx by dt. So as we have to find the rate of change of y, which is dy dt, we already have dx by dt, so we have to find dy dx and then multiply to get the value for dy dt. So now in the first step, as y is equals to 5x minus 1 to the power half, we'll first differentiate it. So differentiating this, we'll get dy by dx. So half multiplied by the coefficient, which is 1. So this will be half into 5x minus 1. and the power reduces by 1. So this will be minus 1 upon 2. And this will multiply by the derivative of 5x minus 1, which is 5. Now, once we have this, we have to substitute x equals to 1. So this will become 1 upon 2 into 5 into 1 minus 1 to the power minus 1 upon 2 multiplied by 5. We can simplify this to write it as 5 upon 2. And this will be this will become 4 to the power plus half in the denominator. So that value for dy dx will be 5 upon 8. Once we have the value for dy dx, we'll multiply it with the value for dx by dt. So dy dt will be equals to the value for dy dx, which is 5 upon 8, multiplied by the value for, so, and this will be, this is a small change over here, and this will be 5 upon 4, as square root of 4 is 2. So this will become 2 times 2, which is 4. So dy by dx is 5 upon 4, multiplying by dx by dt, which is 2. So this will cancel out. And the final answer for dy by dt will be equals to 5 upon 2. In part B, it says find the value of x when the y coordinate is increasing at 5 upon 8 units per minute. Now, we know that the rate of change of x is 2. The rate of change of y is given in this case as 5 upon 8. So again, writing the formula dy by dt will be equals to dy by dx into dx by dt. So we know that dy by dt is 5 upon 8. Dy by dx we found in the previous part, that was 5 upon 2. So that was 5 upon 2 into 5x minus 1 to the power minus half, multiplied by dx by dt, which is 2. So this 2 and this 2 will cancel out. This 5, when it divides over here, so that will cancel out with the 5 as well. So this will also cancel out. So we'll have 1 upon 8, that will be equals to 5x minus 1 to the power minus half. We can take the reciprocal to make 5x minus 1 to the power minus half as positive. So we can write it as 1 upon 8 is equals to 1 upon 5x minus 1 to the power half. So we can equate 5x minus 1 to the power half, and that will be equals to 8. Now taking the square on both the sides to get rid of the power 1 upon 2. So whole square in both the sides, we'll get 5x minus 1, that will be equals to 64. So 5x will be equals to 64 plus 1, which is 65. So the value of x will be 65 upon 5, which is equals to, so that will be equals to 13. Question 7, we have to prove in the first part, we have to show that tan upon 1 plus cos plus tan upon 1 minus cos as an identity of 2 upon sine cos. So to prove that, we can start off by just simply taking the LCM. So the LCM will be 1 plus cos and 1 minus cos. So tan will multiply it by 1 minus cos, and this tan will multiply by 1 plus cos. Simplifying this, we'll get tan minus tan cos plus tan cos is equal upon 1 plus cos 1 minus cos. And we can factorize 1 plus cos 1 minus cos and write it as, so we can use the identity x plus y and x minus y can be written as x squared minus y squared. So we can write it as x 1 plus 1 minus cos squared. Now in the numerator, minus tan cos and plus tan cos will cancel. So we'll have 2 tan in the numerator and 1 minus cos squared in the denominator. And in the denominator, we can apply the identity, which is sine squared plus cos squared is equals to 1. So sine squared is equals to 1 minus cos squared. So in the denominator, we can write sine squared in place of 1 minus cos squared. Now, as we need the equation in terms of expression in terms of sine and cos, so in place of tan, now we can write sine upon cos. So we know that tan theta is equals to sine theta upon cos theta. So we can write tan as sine upon cos, and there was already a sine squared in the denominator. So this sine and this sine will cancel out. So we'll get 2 upon sine theta cos theta, which was the identity that we had to prove. In part B, it says that hence solve the equation tan upon 1 plus cos plus tan upon 1 minus cos equals to 6 upon tan theta. Now we already simplified this expression to write it as 2 upon sine cos theta. So over here we can write 2 upon, so this was sine theta cos theta. And as tan theta is sine upon cos, so this will become 6 into cos theta upon sine theta. So sine theta will cancel out and we'll get cos squared theta will be equals to 2 upon 6. So cos squared theta is equals to 2 upon 6 and cos theta will be equals to square root of 1 upon 3. Now, as we have to find the angle from 0 till 180, so the square root sign comes with both positive and negative. First, we'll find the basic angle by taking cos inverse of square root of 1 upon 3. And we'll have to make sure that the calculator is in degrees mode. So taking shift cos inverse of, and that will be square root of 1 divided by 3. That is equals to 54.7 degrees. So the basic angle is 54.73 degrees. Now, as it can be positive and negative both, and our values of theta have to be from 0 till 180. So this is the first quadrant, this is the second quadrant. However, due to the square root of square root sign, we'll be making 54.73 in the first quadrant as well, and the negative quadrant of cos as well in the second quadrant. So the first angle for theta will be from the positive x-axis anti-clockwise, so that is 54.73 degrees. And the second angle will be 180 minus 54.73 degrees. So the final answer to three significant figures or one decimal place as it is an angle will be 54.7 degrees. And the second answer will be 125.3 degrees. In question 8, the first term of a progression is sine square, where theta is greater than 0 and less than half pi. The second term of the progression is sine square cos square theta. In part A, it's given that the progression is geometric. We have to find the sum to infinity. Now, the formula for sum to infinity is given by A divided by 1 minus R, where A is the first term and R is the common ratio. So we already have the value of A, which is sine squared, and to find the value of R, which is the common ratio, we will divide the second term with the first term. So the second term is sine squared cos squared, and the first term is sine squared. So sine squared and sine squared will cancel. So the R will be equals to cos squared. So the sum to infinity will be written as A, which is sine squared theta divided by 1 minus R. So that is cos squared theta. So this will be 1 minus cos squared theta. Now we can use the identity that sine squared theta is equals to 1 minus cos squared theta. So the sum to infinity can be written as sine squared theta upon sine squared and sine squared will cancel out. So the sum to infinity will be equals to 1. In part B, it says it is given now instead that the progression is arithmetic. We have to find the common difference of the progression in terms of sine theta. So to find the common difference, we find the difference of two consecutive terms. So in this case, we can find the difference of the second and the first term. Now the second term was sine squared and cos squared, and the first term was sine squared. Now we have to bring our expression in terms of sine theta. So we can again use the identity, which is, so cos squared is equals to 1 minus sine squared. Now substituting 1 minus sine squared in place of cos squared. So we'll get sine squared into 1 minus sine squared minus sine squared. Expanding the bracket, we'll get sine squared minus sine to the power 4 minus sine squared. Sine squared and sine squared will cancel. So the common difference will be equals to minus sine to the power 4 theta. In part 2, it says find the sum of the first 16 terms when theta is equals to 1 upon 3 pi. So if we have an arithmetic progression, the sum of n terms is given by n upon 2 into 2a plus n minus 1 into d. Now we know that the common difference is sine to the power 4 theta and a is sine squared theta. So substituting the values of a and d, and n is 16. So we'll write it as 16 upon 2 into 2a. So that will become 2 into sine squared plus n minus 1. So that is 16 minus 1, which will become 15. And d is minus sine to the power 4 theta. Now first finding the values of sine square and sine to the power of 4. So we know that theta is 1 upon 3 pi. So we can write it as sine A will be equals to sine of 1 upon 3 pi whole squared. Now as sine of 1 upon 3 pi, if we substitute this in the calculator, that is equals to root 3 upon 2. Whole squaring root 3 upon 2 will get A will be equals to, so root 3 whole square will be 3 and 2 squared is 4. So A squared will be 4 and D will be, so as D is minus sine to the power 4 theta, so we'll write it as minus sine of 1 upon 3 pi and that will be to the power 4. Sine of 1 upon 3 pi, we know that is root 3 upon 2. So root 3 upon 2 to the power 4, substituting this in the calculator. So this will become 9 upon 16. So D will be equals to minus 9 upon 16. Now to find the sum, we'll just substitute the values of A and D into the equation. So that will become 16 upon, and this will be 16 upon 2 up here. So this will be 16 upon 2, and this will be 8 into 2. A is 3 upon 4, plus this will be 15 into 9 upon 16 with a negative sign. Simplifying this, we'll get sum of n terms will be equals to 8 multiplied by, so this will cancel out, this will become 3 upon 2 minus, and we can write this as 9 times 15. So 9 times 15, if we substitute this in the calculator, that is equals to 135. So this will be 135 upon 16. Now substituting these values in the calculator, so we'll get sum of n terms will be equals to 8 multiplied by, taking the LCM will be 16. So this will be 16, and as this will multiply by 8, so this will also multiply by 8. We'll get 24 minus 135. 8 will cancel with 16. 24 minus 135, that is equals to minus 111. So the sum of n terms will be minus 111 divided by 2, or in terms of mixed fraction, we can write it as minus 55 wholes 1 upon 2. In question 9, functions f and g are defined by f of x equals to x square minus 4x plus 3 for x greater than c, where c is a constant, and g of x is 1 upon x plus 1 for x greater than minus 1. In part A, we have to express f of x in the form x minus a whole squared plus b. So we can use the complete, we have to convert this into the complete square form. So we can use the comparison method over here to convert the equation, which is x squared minus 4x plus 3. And we can write this in the expanded form. So this will become x squared minus 2ax plus a squared plus b. To find the values of a and b, we can compare the coefficients of x on the left and the right hand side. So on the left hand side, it is minus 4. On the right hand side, it is minus 2a. So minus 2a, we can write it as minus 4. And a will be equals to positive 2. To find the value of b, we can compare the constant terms. So on the left-hand side, it is 3, and on the right-hand side, it is a squared plus b squared. The value of a is 2, so this will become 2 squared plus b squared equals to 3, and b squared will be equals to 3. So this will become 3 minus 4, and b squared will be equals to, and this is not a b squared, this is just a b, so this will be a squared plus b. So a squared plus b is 3, so b will be equals to minus 1. Once we have the values of a and b, we can write this as x minus 2 whole squared minus 1. In part B, it says it is given that f is a one-to-one function. We have to state the smallest possible value of c. Now, for a function to be one-to-one, it means that it can only have one value of x for one value of y. And from the previous part, we know that the turning point is at 2 and minus 1. So the smallest possible value for this function to be one-to-one, and we know that x is greater than c. So this means that it has, for it to be a one-to-one function, the quadratic graph must start from this point, and it will be like this. So the smallest possible value will be x will be equals to 2, or we can write c will be equals to 2. And if there was any other value lesser than 2, the graph will not be one-to-one as it will be going upwards. So for each value of y, we'll have more than one value of x. So the only possible smallest value is c will be equals to 2. In part C, it says that it is now given that C equals to 5. Find an expression for F inverse and state the domain of F inverse. So to find an expression for F inverse, we have to first convert our function into the full square form, which we already did in part A. So that was x minus 2 whole squared minus 1. To find the inverse, first we'll write y over here and write this expression as it is. Now exchanging the values of x and y, so this will become x is equals to y minus 2 whole squared minus 1. Taking 1 on the left hand side, so this will become x plus 1 is equals to y minus 2 whole squared. Taking the square root on both the sides, so we'll get the square root of x plus 1 equals to y minus 2. Taking 2 on the left hand side, we'll get y is equals to 2 plus square root of x plus 1. So finally, we can write the expression for F inverse of x as 2 plus square root of x plus 1. Now to find the domain for F inverse, so for a function f of x, the range is equal to the domain of the function. So first we can find the range of the function f of x. Now as the value of c is 5 or c is the value of x, so finding the range of f of x, that will be, so substituting x equals to 5, we'll get 5 minus 2 whole squared minus 1. So f of x will be equals to 5 minus 2 is 3, 3 squared is 9, so 9 minus 1 is 8. So we can write that f of x will be greater than 8. So as the range of f of x is greater than 8, it means that the domain of f inverse will also be greater than 8. So we can write it as that the domain for f inverse will be x greater than 8. In part B, it says find an expression for g f of x and state the range of gf. Now to first find the function g of f, we will substitute in the function g. In place of x, we'll write the whole function f of x. So the function g was 1 upon x plus 1. So we'll write it as 1 upon x plus 1, and in place of x, we'll write the function f, which is x minus 2 whole squared minus 1, and this was plus 1. So this will be a plus 1 up here. Minus 1 plus 1 becomes a 0. So the expression for g of f of x will be 1 upon x minus 2 whole squared. Now to find the range of g of f, what we first must understand is that in the function g of f, in place of x, we have the values of f of x. So, and f of x was x is greater than c, and for g of x, x was greater than minus 1. So we can see that this function f of x must be greater than minus 1. So the function f of x was x minus 2 whole squared minus 1, and as the domain for g of x was x greater than minus 1, so we can write that this will be greater than minus 1. So solving this equation, we can write it as x minus 2 whole squared will be greater than, so my 1 will go on the right hand side, this will become minus 1 plus 1. So this will be x minus 2 whole squared, and that will be greater than 0. So the values of x will be 2 and minus 2 up here. But over here in this case, we also have to take in the consideration the values of f of x. Now f of x, we know that it had to be greater than c. And the function g of f was 1 upon x minus 2 whole squared. So taking values of x for g of x, which were greater than minus 1. So if we substitute minus 1 up here, so let's say if I substitute x equals to minus 1 up here, this will be 1 upon minus 1 minus 2 whole squared. And this will be equals to 1 upon 3 whole squared, which is equals to 1 upon 9. Now, as I keep on increasing the values of x over here, and we know that the function g of x again should be greater than minus 1. Now, x is greater than minus 1 basically means that x could be anything above minus 1, which is 0, 1, 2, 3, 4, and so on. Now, as I keep on increasing the values of x, the value for the denominator will keep on increasing, and 1 upon a very high value will basically become a 0. So the maximum value for g f of x that we can get over here is 1 upon 9. Any other value of x that we substitute over here will give us a value which is less than 1 upon 9. And a very huge value of x will give us a value which is near 0, but it will not be equal to 0. So the range for g f of x will have to, it will be greater than 0 as it can never reach 0. X can be infinity at the point where g of f of x will become a 0, and the maximum value for g of x will always be 1 upon 9, as x has to be greater than -1 for g. So even if we take these values of f of x, they will give us the value x equals to 2. But solving this separately, as even if we substitute 2 over here, that will become 2 minus 2, which is a 0. So 1 upon 0 will become an infinity, which is basically not possible for g f of x. The maximum possible value it can take is 1 upon 9. So the final answer for the range of g of f of x will be equals to greater than 0 and less than 1 upon 9. In question 10a, the coordinates of 2 points A and B are -7, 3, and 5, 11 respectively. We have to show that the equation of the perpendicular bisector of AB is 3x plus 2y equals to 11. So in the first step, to find the equation of the perpendicular bisector of AB, we'll first find the gradient of AB. So that will be y2 minus y1 divided by x2 minus x1. That will be equals to 11 minus 3, 8 upon 12. Simplifying this, the gradient will be equals to 2 upon 3. So as the gradient of AB is 2 upon 3, the gradient of the perpendicular bisector will be the negative reciprocal. So we can write that the gradient of the perpendicular bisector will be equals to negative 3 upon 2. Now the perpendicular bisector will pass through the midpoint of AB. So in the next step, we'll find the midpoint of AB. The formula for the midpoint is x1 plus x2 upon 2. So that is -7 plus 5 upon 2, comma 3 plus 11 upon 2. Simplifying this, we'll get -2 upon 2, which is -1, and 11 plus 3 upon 2, which is +7. Once we have the midpoint and the gradient of the perpendicular bisector, the equation will be y minus y1, which is 7, and it will be equals to the gradient m, which is -3 upon 2 into x minus x1. So as x1 is -1, so this will become minus, it will become a +1. Cross multiplying, we'll get 2y minus 14 is equals to -3x minus 3. 3x will go on the left hand side, so this will become 2y plus 3x, and this will be -3 plus 14. Simplifying this, we'll get 2y plus 3x is equals to 11, which was the equation that we had to prove. In part B, it says a circle passes through A and B and its center lies on the line 12x minus 5y equals to 70. We have to find the equation of the circle. Now to understand this question, first, let's make a circle over here. And we know that A and B lie on the circle. So A and B lie on the circle somewhere. And the center of the circle lies on the line, which is 12x minus 5y equals to 70. So let's say this is the center and it lies, and it has an equation. The line has an equation. So it's not necessarily a diameter, but the center lies on the line. So we can just say that this line has an equation of 12x minus 5y equals to 70. Now in the previous part, we found that the perpendicular bisector of AB had the equation which was 2y plus 3x equals to 11. And if we have 2 points on the circumference, and if we make a perpendicular bisector from this point till the center, it basically makes a right angle up here. So from the center, it makes a right angle. And as we already have the equation of this perpendicular line, which was 2y plus 3x equals to 11. So this equation was 2y plus 3x equals to 11. If we solve these two equations simultaneously, we'll be able to find the coordinates of the center. So one of the equations is 2y plus 3x equals to 11. The other equation is 12x. So we can write it as -5y plus 12x is equals to 70. To solve it simultaneously, we can first make the x values equal. So we can just simply multiply this equation by -4. We can also make the y values equal. So it depends. In this case, I'm just making the x values equal, and we can multiply this by 1. So the first equation will become -8y minus 12x is equals to -44. And this will be -5y plus 12x is equals to 70. So 12x will cancel. -5 minus 4y is a -13y, minus 44 plus 70, so that will be equals to, I think that's a positive 26. Y will be 26 divided by minus 13, which is equals to minus 2. Once we have the value of y, we can substitute this into either of the equations to get the value of x. So using the first equation, we will get 2 into minus 2 plus 3x equals to 11. So 3x will be equals to 11 plus 4, as this will be a minus 4 up here. So this will be 3x is equals to 15 and x will be equals to 5. So we now know that the center has the coordinates 5 comma minus 2. Now to find the equation of the circle, we also need the radius. To find the radius, we can find the distance of the center from point A or from point B. Either ways, the radius will be the same. So the coordinates of point A are minus 7 and 3. And the coordinates of point B are 5 comma 11. So we can use any of these two coordinates. Well, let's use the coordinates of B to find the distance or the radius. So the radius will be equals to, we can say, the distance of the center from B or the center from A. So finding the distance CB, C is the center and B is the point on the circumference. So we can use x2 minus x1. So that will become 5 minus, so both have coordinates 5 in this case. So that will become 5 minus 5 whole squared plus, and the y coordinates will become minus 2 minus 11 whole squared. So this will be minus 2 minus 11 whole squared. 5 minus 5 is a 0. So the coordinates of CB, the distance of CB will be equals to 0 squared plus minus 13 squared, which is equals to square root of 169. So the radius will be equals to 13. Once we have the radius, we can write the final equation, which is the general form for the equation of a circle is x minus a whole squared plus y minus b whole squared, which is equals to r squared. A and b are the coordinates of the center. So we can write this as x minus 5 whole squared plus, so as b, the y coordinate for the center is minus 2. So this will become a plus 2 whole squared. And the radius is 13. So 13 squared will become a 169. So the final equation of the circle will be x minus 5 whole squared plus y plus 2 whole squared is equals to 169. In question number 11, the diagram shows part of the curve with the equation y equals to x cubed minus 2bx squared plus b squared x, and the line OA, where A is the maximum point on the curve. The x-coordinate of A is A, and the curve has a minimum point at b comma 0, where A and b are positive constants. In part A, we have to show that b equals to 3a. Now, as A is the maximum point on the curve, we know that the dy dx at this point will be 0. So the equation is y equals to x cubed minus 2bx squared plus b squared x. So first finding the dy dx. So the dy dx will be equals to 3x squared minus 4bx plus b squared. As the derivative of x is 1, so it will only be b squared. Now we'll substitute 0 in place of dy dx, and this equation will be 3x squared minus 4bx plus b squared. Now the x coordinate at the maximum point is a, so we can write this equation as 3a squared minus 4ab plus b squared equals to 0. Factorizing this equation, we'll get 3a squared minus 3ab plus minus ab plus b squared equals to 0. Taking 3a common, we'll get, this will become a minus b, and taking b common over here, we'll get a minus b equals to 0. Simplifying this, we'll get a minus b, and 3a minus b equals to 0. So the values will be, one of them will be a equals to b, and one of the values will be 3a equals to b. So as it is 3a minus b equals to 0, so we can take b on the other side and write it as b equals to 3a. Now, one of the values a equals to b we already have, which is the maximum point, and the other point will be where b will be equals to 3a. So we had to prove b equals to 3a. So here we have that b will be equals to 3a. In part B, it says that show that the area of the shaded region between the line and the curve is Ka to the power of 4, where K is a fraction to be found. Now, to find the area of the shaded region, first we can find the area under the curve with the limits a and 0, and then find the area of this triangle OA and the point that is intersecting on the x-axis. So first finding the area of the triangle, we know that the base is A, and to find the height, we'll have to substitute x equals to A. So the equation of the curve is y equals to x cubed minus 2bx squared plus b squared x. Now we know that the value of x is A, so substituting A over here, we'll get y will be equals to A cube minus, and as we know that b is equals to 3a, so in place of b, we can write 3a into a squared, and this will become 3a whole squared times, and x is a. So y will be equals to a cube minus, this will become 6a cube plus, so this will become 9a squared into a, so that will become a 9a cube. Simplifying this, we'll get a 1 minus 6 minus 5 minus 5 plus 9, so that will be equals to, so that will be equals to 4a cube. Once we have the height of the triangle, which will be 4a cube, so the area of the triangle will be equals to 1 upon 2 into base, which was a, and the height, which is 4a cube. So this 2 and this 2 will cancel out. So the area of the triangle will become 4a to the power 4. Now to find the area under the curve, so we'll integrate the equation of the curve and we'll use the limits as a and 0. So the equation of the curve is x cubed minus 2bx squared plus b squared x. And we write a dx when we are integrating, and the limit in this case will be a and 0. So in the first step, integrating this, so integrating x cubed, that will become x to the power 4 upon 4 minus, this will become 2bx cubed to the upon 3. This will become b squared. So this, the x will increase by 1, the power of x will increase by 1. This will become x squared upon 2. Now we can substitute in place of b. We know that b is equals to 3a. So we can first write x to the power 4 upon 4 minus. So this will become 6ax cubed upon 3. And this will become, so substituting 3a up here, that will become 9a squared. So just directly writing 9a squared over here, we get 9a squared x squared upon 2. Now substituting the value of x, so the upper limit is a, so this will become a to the power 4 upon 4 minus, so this will cancel out, we'll get 2a and x is a, so this will become a cubed, so this will become 2a to the power 4, and this will become plus 9 upon 2, and x squared, so this will become a to the power 4, as x is a. Now, when we substitute x equals to 0 over here in all of these three terms, it will become a 0, so we can leave it as it is. Now, simplifying this first, taking the LCM over here, so the LCM is 4. Simplifying this, we'll get, so this will be 4, and this will become a to the power 4 minus, this will multiply by 4, so this will become minus 8a to the power 4, and this will multiply by 2, so that will become plus 18a to the power 4. So 1 minus 8 is minus 7. Minus 7 plus 8 will become 11. So the area under the curve is 11a power 4 upon 4. And once we have the area under the curve, which is 11a to the power 4 upon 4, we can find the difference to find the shaded area. So the area of the shaded region will be the area under the curve, which was 11a to the power 4 upon 4 minus, and the area under the triangle was 4a to the power 4. So this would have been 2. This is a 2 up here. So this will be 2a to the power 4. So 11a to the power 4 minus 2a to the power 4. So taking the LCM, 11. So this will become 4 times 2, 8. So 11 minus 8 will become 3. So the answer will be 3a to the power 4 upon 4. And as we had to give our answer in terms of k, a4, where k is a fraction, so the value of k in this case will be 3 upon 4.